Hi there, and welcome to today's webcast. I'm John Gamble, Director of Product Marketing here at Corelight. We'll get started in just a minute. We're going to give people another minute to log in before we get started, so just hold tight, and we'll get started in a minute. Thank you. Okay, let's begin. Welcome to today's webcast, Hunting for Insiders with Network Deception, presented by Corelight and Traced. I'm John Gamble, Director of Product Marketing, and I'm joined today by Matt, founder of Traced. Matt, perhaps you could give the audience a bit about your background.
So good afternoon, everyone. We're happy to be here and glad you're taking the time to listen to this webinar. Before we jump into it, my name is Matt Hosberg, founder of Trace. I've got about 2 decades of kind of offensive and defensive security experience, working both in oil and gas, government, financial services, and for several startups. Happy to be here and look forward to showing what Trace and Corelight can do.
Excellent, thanks, Matt. And I run product marketing here at Corelight. I've been with Corelight for about 3 years, and I've spent my entire career in the broader security industry, representing a range of products across privacy, security technologies, and ID verification technologies as well. And today, I'm very excited to talk about a topic that we at Corelight haven't really talked about before, which is deceptive technologies and what you can do when you marry them with security monitoring of your network. So just quickly, the agenda. We'll talk about different deception techniques, the benefits of deception. Matt will walk us through that section. Then I'll pick up the thread and talk about network security monitoring and why that visibility is so important. And then the third part of this agenda is really the meat of today's presentation. Matt will be kind of taking those 2 concepts and putting them together in a demonstration of how you can actually set up a deceptive trap in your environment and monitor it on the network side and see exactly what's happening in terms of an insider threat. Then we'll quickly kind of outline the Traced and Corelight product offerings, and we'll close with a Q&A. And if you have questions, feel free to ask them at any point during the presentation via your questions tab. We'll be monitoring them, and we're going to save Q&A for the end. And lastly, a recording of today's presentation will be made available, so you can share this with colleagues who weren't able to join or watch it later if you have to drop off early. So with that, let's get started. Matt, I'm going to turn it over to you to talk about network deception.
Sounds good. Thanks, John, for that intro. So why network deception, right? This may be a term that's new to you. Maybe it's been around and you're rattling around in your brain for several years at this point. Regardless, I want to start with framing this a little bit, right? So when we talk about denial and deception, there's kind of this notion of this classical denial and deception, which over the years has been used in war, politics, marketing, and all the things like that. Now, one examples that I like to start with is basically one of the most famous uses of deception was back in World War II. Around the Normandy invasion, there was this operation called Operation Bodyguard. And it was essentially kind of this masterful deception plan with the purpose to mislead the German army and conceal the real location of this Allied invasion that was supposed to take place. The plan actually started with this quote unquote leak of top secret information that outlined these allied targets. And ironically though, if you know much about this operation, the documents that were quote unquote leaked were actually real. The thing about what helped the Allies was they actually put out fake information prior to this actual mishandling of information. And the German army didn't believe that those were real. They didn't think they were that lucky. And so by being fooled previously by this false information, the Allies leveraged some of this misinformation as a weapon to influence the Nazis' decision-making process, right? So fast forward a little bit closer to the actual invasion. They had they hired artists to create these blow-up tanks, which is what you're seeing at the top right. Essentially, blow-up planes, paratroopers, that all looked real from afar, right? So if you were doing any type of aerial reconnaissance, these things looked like the real deal. Now, obviously, if you're standing right next to them, you could tell that there's something not quite right. But basically, these decoys were leveraged to signal to the Germans that they were actually the Allies were going to be attacking from those suspected areas, right? And so this gave the Allies the upper hand at an already challenging invasion. If you ever spend any time over, I've actually walked the beaches of Normandy, and they are very long, very expansive. And so to be a soldier assaulting that beach is already a daunting task. So we needed every advantage. We needed to use every advantage. So with that said, it was a success. It was a very decisive invasion. Still cost a lot of manpower, unfortunately, but it was a very masterful level of deception at scale. More recently, in the 2016 election, we have kind of an example from the Internet Research Agency that used information to essentially influence public opinion, right? And that's pretty evident and well documented. And then the bottom kind of left right there, marketing, like what we're doing right here today. Sometimes you may have noticed something as advertised doesn't quite look what it should like, doesn't quite look the same as it does in reality, right? It's ironic, but it's true, right? I mean, that's just the quality maybe of something like that. So you see, deception isn't just about presenting a fake of something like a honeypot or a decoy, and we're going to talk about kind of what those mean, but it's really a larger plan that helps to influence the decision an adversary is making, right? So the idea, back to the case of D-Day, the Allies knew the Germans would conduct aerial reconnaissance to gather that intelligence, and so they used those decoys in conjunction with that to basically help inform what the Germans were looking for. All right, so as we kind of frame this more into our current state of affairs, right? We want to talk about, everyone knows MITRE, right? Everyone knows MITRE's enterprise framework. But actually what I want to spend a little time on today is the pre-attack framework. So this is essentially the framework that an adversary may use, and maybe not in order or anything like that, but these are the type of things that as an attacker you have to identify before you actually launch your attack. So for example, we have to define a priority, we have to select the target, and then during that whole phase, they might start branching out and looking for technical information, right? Conducting scanning of that organization and its systems. They might do some open source intelligence gathering around the personnel that are associated with that organization. They might try to figure out what other third parties and infrastructure is leveraged. And then identifying all of that, they start to work through maybe what those weaknesses are. Maybe it's a technical thing, maybe it's through personnel, and that's how they start to formulate that attack, right? And so the question I would pose, right, is what if we could actually, what if it was possible to detect this activity as early as possible, right, to learn about what the attacker is after and to inform our defenses, right? Wouldn't this help with prevention? Wouldn't this help to uncover those techniques and procedures and attackers leveraging against the organization? And my answer to that is absolutely, right? And if we focus on the latter and we wait for the attacks to actually manifest themselves in our organization, in my mind, in a lot of cases that might be too late, right? So if we think back to Operation Bodyguard, right, that fake information that was real, or that leaked fake information, but it was actually real, and they were in their early stages of planning, it actually changed their mind on where they would attack or even mass their troops, right? So that's very similar to this pre-attack. If we can inject that information to influence that decision-making process as early as possible, it can have some cascading effects and even allow us to maybe potentially redirect that attack earlier before it actually takes place. And so let's just take a quick pause right here to talk about what deception kind of means, right? So we all have this notion of like what a honeypot is. I would imagine most of the folks on this call understand what that is, right? And honeypots, in my mind, are essentially some type of computer system that is mimicking a real system. So it's like an emulation of a system to produce return certain results, to interact so that it can be interacted with. And what we kind of move into the next one on our honey nets, it's really just a collection of all those honeypots together. For today's scenario, we're actually going to walk through more of the honey tokens and the decoy systems. And so what's different about all that, right? Well, honey token essentially is not a full computer system. It could be a value, could be a record in a database. It could be a file, and a decoy, right, could be an actual licensed operating system that's, if it wasn't purposed for deception, it could actually stand alone and provide some maybe business function, for example. So in my mind, honeypots, honey nets are more emulated. A decoy system is actually a full-blown, very, very difficult to detect whether that's a decoy or not. I want to make that distinction. If you have spent any time, I just put a couple examples here, but the Conpot, right, which is an ICS honeypot, the HoneyNet project, great resource. We're talking a little bit about actual word honey tokens today, and our decoy system, which actually is based on an Amazon EC2 instance. So why deception, right? Why if we have all this security tooling, if we have we spent all this time and effort to defend our organization, why would we even want to consider something like this, especially when we're talking about alerting earlier into that pre-attack framework? Well, the big thing to take away is that we don't actually need big data. So a lot of the most savvy security teams and organizations struggle with finding that signal in the noise. You know, and if I asked show of hands, how many of you have had a hard time prioritizing alerts, or if you're exhausted just looking at the same thing over and over, my assumption is that your hand is up. Mine is up. And so over the years, I've realized that as a security operator, as a threat hunter, I wanted really good threads to pull for investigation. I didn't have all the time, I didn't have all the resources in the world to spend looking at every alert, tracking down everything. So I needed something a little bit more better fidelity, essentially. And so instead of relying on those patterns or having to try to boil the ocean, trying to get every single log into our SIM, or every single log into some type of fancy tool that would spit out the top talkers, for example, we don't need that. We don't need to train machine learning for a lot of this. For example, we're not looking for like a baseline. We're not looking for anomalies to that baseline, for example. And again, at the end of it, we're really looking for good threads to pull. And so most importantly, we want to influence, though, or change that attacker's actions. And what I mean by that is, if you're familiar with the OODA loop, which is observe, orient, decide, and act, right? We want to essentially change what they're observing, or at least present what they're observing, so that they can orient and decide and act on what we're telling them, versus waiting for them to actually be in the environment and them reacting to actual systems and data and networks. The thing about deception, before I turn this back over to John for a few minutes here, is we need a hypothesis, like a threat hunt. So if you're familiar with hypothesis-driven threat hunting, we essentially take, we formulate a hypothesis before we start looking for the bad things in the network. So similar to deception, or I guess in concert with deception, we're actually formulating a hypothesis to say we might actually have a problem. We might have a new product that we're afraid could leak into our competitors' hands. We might have a problem with, data loss, for example, in that regard. So we want to create a deception plan around maybe an insider threat or data loss in that example. And then finally, with that plan, we don't want to keep it open-ended. We want to keep it limited to a time scope. And the reason why we do that is because we want to try to keep it as valid and relevant as possible, and to hopefully measure the kind of the efficacy of that deception plan. So with that, I will turn this back over to John to talk about, get my mouse to work, why network visibility is important for this whole deception plan.
Thanks, Matt. Yeah, so let's say, imagine you've got an intent to deceive. You've picked a mechanism, right, like a honeypot or a honey token to deceive your adversary. You formed a plan and a hypothesis around how you're going to do that. But what about the other piece of this puzzle? You might catch them in the act, right, with one of these deceptive techniques. But let's say you want to go back in time and figure out what they were doing before they jumped into that protected kind of deceiving environment, or where they go after they grab that document. Maybe you want to go back in time and say, hey, now that I have some IOCs around this actor, maybe I want to go back and look across my network over time and say, did this host connect to any other systems in my environment in the last 2 weeks? A simple question like that, right? Well, those are the kind of questions that you're going to need broad, but also deep and actionable network visibility to be able to pull on those threads. Once you've got those threads identified with a deceptive technique and someone actually triggers it, now you want to pull on those threads. Network visibility is where you're going to probably be going next. So I like to show this diagram here because I think it drives home an important point, which is that, the Hollywood breaches that are all special effects driven make it look like hacks happen in a matter of seconds. And the reality is that typically sophisticated breaches are measured in months, not minutes. It's a very slow, deliberate process where an adversary is exploring and moving across systems deliberately, trying to avoid detection, trying to go low and slow as they break into systems and accounts and credentials. And this particular stat comes from the FireEye 2019 Trends Report. It says the average adversary dwell time, the amount of time they go undetected in your environment, is nearly 3 months. And so all of those adversarial movements, right, connecting from their host machine into a protected asset they've been able to gain access into, moving laterally from there, calling back to their C2 server, all of those kinds of movements are leaving a network footprint behind. And that's an opportunity for you to identify that sort of behavior. But that's also true of deception techniques. Let's assume that you're successful in rerouting the adversary at the beginning of that attack, right? And so you've successfully routed them into a protected environment where they think they're breaching your environment, but in fact, they're just in one of these, honeypot-like scenarios where they've actually taken the bait and they're running with it, and they think that they've actually made successful contact, but in reality, you've just trapped them and rerouted them. You also want to be able to monitor that activity as well, and connect it back potentially to other network activity in your environment that isn't being identified by the honeypot that may look otherwise benign. And so people tackle this strategy today typically with a variety of data sources that you're seeing here on the left-hand side, right? Security folks tend to grab what's available in their environment, and that is often data that's controlled by the IT team, right? So, you might not have your DNS server records logging turned on because the IT team doesn't want them to impact DNS server performance, and so therefore you're not getting DNS visibility as a security team. You might be collecting NetFlow off of your routers. You might also be doing full packet capture. You might be collecting a rolling, 24 hours worth of full packet capture on your network for analysis. And these are typically the strategies that we see a lot of security teams out there using to get that network visibility, to answer those questions that I talked about earlier, and pull on the threads once you've got somebody triggering one of these deceptive technologies. The challenge, of course, is that most of these logs were never designed for security teams. I mean, they were designed typically with IT use cases in mind, right? A DNS server record or an SMTP server record is really oriented around troubleshooting, performance optimization, IT use cases around that physical hardware in your environment. So does it contain security valuable information? Sure, but it also leaves out a lot of information that security teams would be interested in knowing about because it's not relevant to those IT use cases. Also, those logs tend to be in disparate data formats. You hope that your timestamping is aligned across all of these different logs, but often the case is it's not. It may use a different timestamp format. Timestamps may be misconfigured on certain servers, and suddenly you've got logs that don't match up at all with what you expect. These are the kind of challenges. I like to call it a bad puzzle game that security analysts are often playing in their SIM when they're trying to kind of connect these logs together and make sense of what's essentially gaping visibility holes in between those kind of data footprints there. Now, on the full packet capture side, it's great if you have the packets and you know exactly where to look, but most people aren't storing packets beyond a few hours, a few days, maybe a few weeks maximum, in terms of full packet capture storage. It gets very expensive very quickly to store data at enterprise scale. We're talking about petabytes worth of data very quickly on large networks. And so most teams are only storing, a few days, a few hours, a few weeks, maybe worth of network traffic, which means when you need to forensically analyze something that happened a month or 2 months ago, you're out of luck. There's just no packets there because they've been wiped and overwritten. And even when you do have the packets you're looking for, it can be pretty challenging to identify the specific packets and kind of time frame that you're looking for. And it can take hours in Wireshark to kind of manually pull apart these packets and answer a single security question, right? It's a whole journey sometimes to get to that single insight, which, security is all about time. And if you can be faster, because you know your adversary is, it would probably behoove you to do that. So there's certainly a role for packets to play, but they often have these downsides as well that I outlined. So this is actually kind of what we recommend, right? We recommend resolution that gives you insight into the entire environment over that 3-month time frame, but isn't full packet capture. It doesn't incur the same storage costs or search costs of full packets. And that's what Zeek is. And if you haven't heard of Zeek before, open source Zeek is an incredibly powerful, nearly 2-decade plus old open source security platform that does network security monitoring and does 3 things exceptionally well. It takes all your raw traffic and transforms it into rich, security optimized logs. It extracts and reassembles files off the network. And it also comes with its own scripting language. You can actually script custom behavioral insights. Anything you can imagine, you can script in Zeek in terms of a behavioral insight trigger. And so Zeek is that Goldilocks in between those IT logs and PCAP, where it gives you the resolution you need, but in a data size that's an orders of magnitude less than packets, which means you can store it for weeks, months, years in some cases. There's open source Zeek users out there that actually have literal years worth of records, a time machine of their network that goes back, almost a decade. So you can start to do things like that. And also this data format was built for security use cases. So it includes the data you're looking for, but it's also built for lightning fast pivoting and searching. And so all of the logs it generates are tightly interlinked and designed for fast pivot. More specifically, what does that mean? Well, I've shown a couple example logs here that Zeek generates. Zeek generates dozens of different log types covering many, many different protocols. These are just a small selection of some of the logs that Zeek can capture. Going left to right, and don't worry about reading the fields, they're too small probably to read on your screen, but what you should get from the slide conceptually is these logs that you're seeing here are in many cases protocol-specific logs, right? So an HTTP session generates an HTTP log. A DNS request generates a DNS log, et cetera, et cetera. Zeek also generates a log for every file that crosses a network. That's that purple log, the fourth to the right there, which means every file that crosses the network, you're getting detailed information about that file. Its MIME type, its SHA-256 hash, for example. All the way on the left, you see the con log. That's the master connection record of this logging framework. It's kind of like NetFlow, and we'll talk a little bit about it on the next slide, but it's the overall connection reporting log. And all of these logs are connected, and those color-coded boxes you see that are linking these logs together, those are the pivot points. Those are those fast pivot capabilities that this logging enables that you're not going to get out of something like an IT log, like a DNS server record where you're trying to align the timestamp with a NetFlow record, right? That doesn't exist in Zeek's world. Zeek's all seeing and all logging. And so not only are you getting a timestamp that's uniform across all of these logs, but you're also getting a UID, which is a unique connection identifier. So every connection gets its own alphanumeric kind of connection identifier that you can click, and it'll illuminate all of the port and protocol activity associated with that connection. So you can very quickly tell a story, right, from left to right and say, a connection was established, an HTTP session and DNS request was made and initiated in an HTTP session. A file was downloaded as a result of that HTTP session. That story that I'm telling you, while simple, can be quite difficult to reconstruct in a world where you don't have data like this at your fingertips. And so to go back to the beginning of this presentation, when you're trying to pull on these threads and investigate, you need to be able to go to data to answer the questions that those thread pulling exercises naturally invite. And this data set is phenomenal for answering those questions. So real quickly, I'm going to preview 3 logs here that you're going to see in the demonstration portion of today's webcast. So the connection log, I mentioned this is kind of like NetFlow on steroids. It's a master record of connections in your environment, but it's also the starting point in a lot of cases for your investigations when you've got Zeek logs in your environment. I won't go through every field here. We don't have time today, but one thing I'll note, if you kind of look in the middle of this log here, there's a lot of detailed information about packets and packet sizes, and you can actually start to analyze at a macro level connections in your environment and start to look at things like producer-consumer ratios and see who's particularly chatty, who's sending a lot of data, who otherwise doesn't send that data. Those are the kind of insights you can do with something like the con log in place. RDP log, okay, so this is a log specific to the remote desktop protocol. It's giving you a bunch of information about this connection, this RDP connection. One thing I'll call out here that's kind of interesting, keyboard layout. That's one of the fields. It's about 5 or 6 down from the top. Doesn't sound that interesting at first glance. Okay, so the machine's using a keyboard and it's this language, so what? Well, let's imagine that you're in a primarily English language organization, right? And you would expect most people using RDP to be connecting with English language keyboards. And suddenly you notice that there's a Cyrillic keyboard layout that's initiated an RDP session. That might be a thread worth pulling on right there. So it's a rich summary of this RDP connection that you can use as part of your investigation. Lastly, I'll call out the SSL log in particular. So this log is generated without decrypting the connection. So Zeek itself does not decrypt traffic, but has immensely powerful capabilities to analyze the nature of the handshakes that are occurring and the certificates associated with those handshakes. And from that, it turns out you can actually squeeze a lot of information out of these connections without actually breaking and inspecting them. And so the SSL log is a great example of that. And you're getting a bunch of rich data here, data about the particular nature of the encryption, the cipher used, the version, the TLS version used. And you can start to do really powerful things, like someone in the open source community of Zeek figured out that you can actually hash and fingerprint SSL connections. And so you can actually start to track encrypted connections and do blacklisting and whitelisting based on that tracking, again, without ever breaking and inspecting. So it's a bunch of rich information, even when that traffic's encrypted. And we call these 3 logs out because you're going to be seeing them in this next section. So Matt, I'm going to turn it back over to you.
All right, John, thanks a bunch. So as we dive into this scenario, you might be asking yourself at this point, okay, so we've talked about deception and we've talked about kind of this network traffic. How does that all tie together? Well, so as I mentioned earlier, we alluded at the fact that could be an insider problem, and that's the scenario we're going to talk about here. And so the scenario that we set up, and again, I'm embellishing a little bit, but a lot of these details are actually either based on real world events or actual kind of deception plans that we've deployed in the past. So in this case, we're suspecting an insider problem. Again, this might be based on some past data leaks that this organization has had, or maybe the fact that we're working on a new product that will make us very competitive, either from a competitor's standpoint, or it's maybe it contains some intellectual property that we just don't want to get out into the public eye. So what do? We take that in this scenario, we've built a deception plan that includes this kind of the fake, but it's a believable story for an interested insider. And in the deception world, they have this notion of breadcrumbs, right? And essentially those are the path back to the system, or let's say decoy, that we want that attacker to go to. And so what a breadcrumb typically is, it's an account. It could be a honey token. It could be maybe a IP address or a connection file, for example. But we've staged those, and ultimately those point to the decoys that we're going to talk about in the next slide. But the goal really is to uncover potential insiders. And really, the idea is to prevent any real data loss and potentially to distract from the real true product or information that we're trying to protect. And again, setting parameters around this deception campaign will help keep it relevant and avoid just kind of this, hey, we've got a honeypot out there, it's been out there for 2 years and we don't really know if it's valuable or not, right? So it keeps it very laser focused. All right, so this is kind of what we're gonna talk about, or we're gonna walk you through here. So back to the notion of we wanna have threads to pull for investigation, right? So in this scenario, as I mentioned, we have a company server. This company server is actually deployed in an AWS environment. It's an EC2 host. It's actually one of our decoys. So we've pre-staged this based on our deception plan. Honey tokens have been scattered throughout that system. And the other kind of call out here is we're actually monitoring that separate AWS environment outside of your organization with a Corelight sensor. So essentially, I know the question is coming, do these decoy systems, honeypots, create additional risk because I'm deploying in my DMZ, for example? In this case, from the trace perspective, this is deployed in our managed system so that the risk is very low, and the systems, let's say they do get compromised, they pose little to no risk to your organization. For the sake of this, we're going to start number one with a callback received from our bugged document that was staged on our company server. So number one, it tells us a couple things. First, we have somebody messing with one of our honey tokens. Two, based on that callback IP address, that source IP address, we can tell that it's from a network range that is outside of our AWS environment. We can tell that the IP address belongs to, let's say, some cable provider that's not associated with our organization. So it tells me that someone's messing with the honey token, and then second, it tells me that that document has somehow left that decoy system. So very, very interesting, and we want to get to the bottom of that. So the next step, number two, like I mentioned, we know that it's left the building, so we want to try to track that down. And then the third question we want to try to answer is, did that same IP log in anywhere to that system? So if this attacker is being sloppy, if they're not even thinking through it, if they're thinking maybe the system isn't monitored, for example, we want to try to pull on that thread first. And then finally, we're going to try to correlate that to the actual user who logged in to maybe give us some more information. Right, when we're dealing with insiders, the one caveat I'll mention too is that there's this notion that an insider is a very technically savvy person. And in a lot of cases, they could be like a rogue administrator, right? That's the proverbial case there. Or they could just be somebody with privileged access that stumbles upon something that seems interesting, and they don't fully understand the technical controls or monitoring that's even in place. So they might act in a way that they think is not being detected, which in this case, they could be wrong. So just throwing that out there, because a lot of times the insider isn't always the most technically savvy person. In some cases they are. So with this scenario, let's dive into it a little bit. So the callback is our first kind of indicator that something's wrong, right? And so this is an actual hit from one of our tokens. It pulls out a few things. Obviously, the time the hit was logged, right? We're pulling out the user agent string, IP address, and some other kind of geolocation around that actual address. So for our scenario here, we're going to take that IP address and we're going to actually use that as our initial thread to pull, just to see what happens. Again, this environment, the decoy, the honey tokens are all pre-staged based on our deception plan. And essentially any interaction with these systems is very interesting, at least, right? So based on that IP address, we're able to see a couple things. Oop, go back one. First and foremost, we're looking for that IP address to see if there's any connections to that decoy system. Now, what we're actually looking at to kind of orient you here. So from left to right, we've got the RDP log, we've got the SSL log, and we've got a connection log, the con log. This data is actually that from that Corelight sensor. The beauty of that sensor that we can deploy in AWS is that due to Corelight's ability to forward these logs along, it's very easy to set up. We're able to actually send these logs directly into our traced platform, which on the back end we're running Elasticsearch. And so what that allows us to do is enrich the data that we've already had. So we have the callbacks from that Word document, but now we're also enriching it with this network layer to help with our investigations. So as I'm looking at that IP address from the source, one, I can see a RDP connection will report 3389 from that particular address. Again, this attacker might be kind of sloppy or lazy, not quite sure at this point. So we start trying to answer to implicate this a little bit more. Secondly, we're looking for how did maybe that document leave that system. Not quite sure at this point, but there is an indicator that a connection was made to pastebin. So maybe that was maybe one failed attempt to, or probing attempt to see if that would be a viable means to exfiltrate that data. Again, in that middle one, we're looking at the SSL log, so we're seeing that web connection over that encrypted traffic. Now we're not, again, looking at the actual payload, but I can see generic connection overlaid with that SSL log. And then finally, in the overall COD log, the attacker seems to actually have invoked some ICMP traffic. In this case, it was a ping back to their IP address, maybe just to test connectivity, maybe to see if there's anything blocked, you know, kind of as this initial phase, right, of discovery of the system, right? So that gives us some a lot more detail of maybe what has happened or has transpired here. So what this next slide actually shows is kind of those different logs and how they're kind of affiliated with the different connections. So first and foremost, at the very bottom, we have our RDP connection, right? So the attacker connecting into that decoy system, monitored through our Corelight sensor, that's where that RDP log is helping us implicate that IP address. Secondly, in that con log, kind of in that middle section, I know it's kind of hard to see it, but essentially that's that system, the decoy system, pinging the attacker system in this case, and that's how we're able to see that through that con log. And then at the top, again, this is just maybe from that decoy system, a probe to see if pastebin's available, or maybe some other you know, cloud hosting provider, so we could stage that file to maybe download it later on our home system. Because again, that initial alert came from an off-prem system that was not affiliated with the enterprise. So really, this slide is just to show you kind of those different phases and where those logs might come into play. And then finally, on our decoy, the beauty of it, right, is we treat our decoys, we often like the decoy more than just like a honeypot, for example, because we're able to deploy our endpoint monitoring solution on there as well. So what that gives us is kind of that granular view into what process, you know, what user was logged in, what files they accessed, what did they do with those files once they accessed them. And it ties that whole, it kind of buttons everything up. So we've taken it from an alert to our investigation over the network to the very granular view into that host system. So almost without a doubt, and because we're not having to sift through a bunch of noise, we have a lot of high fidelity and high signal. Most of this is relevant to our investigation. Now, the caveat here is, first and foremost, we do not label our folders do not enter. We don't label our honey tokens bug doc for real life purposes. It's more to illustrate the concept here. I just want to maybe preempt some questions there. Why wouldn't I make that more believable? And the truth of the matter is we do make those more believable. But again, this is just showing really the detailed view into that host log, kind of piecing it all together, right? In this case, our user, again, embellishing a little bit here, but assuming that same user with those creds that we had previously staged, they use that to log in. Now we have kind of this holistic picture. And you're probably asking yourself, cool story, what do we do next, right? And so that's actually a good question. Now, with this information, right, we can do one of two things, right? If this was a larger deception plan, which is often communicated with the business and worked in conjunction with their kind of business objectives, this isn't just an IT operation fly-by-night type of thing. And the reason is because when we do have evidence or information to share, we want to be able to reach out to maybe that HR team or legal team to say, hey, listen, you know that deception plan that we built out for you? Well, guess what? We're getting some activity on it. Here's what we found. Presenting that to them can help really determine what happens next. right? And if it's a case of very confidential intellectual property that you don't want to leave, there could be maybe some legal ramifications, or there could be some other things that the organization wants to handle. So again, it's about leveraging that capability for some type of action. Now, if we're talking a little bit more of a, we see other techniques on, maybe let's see, we see how that connection attempt happens, or we see how that data is exfiltrated. Any of those techniques or those tactics that were used along the way, really, we want to take those to inform our defenses, right? So it could be in the form of building out watch lists to look for this activity, not just in our decoy systems, but within maybe the larger enterprise. It may be a technique we've observed that we need to build out a threat hunt and go search for that inside the organization. It may actually indicate that we should expand the campaign scope to say, hey, we had one potential insider, go after this fairly rapidly. So maybe we have a bigger problem on our hands, and we need to get our hands around that scope. And it could just be as simple as we need to deploy some more honey tokens or other breadcrumbs throughout the organization to see if that produces any hits or alerts. Right. So those are kind of some of the high level things. Now, there are cases where we've actually helped work with law enforcement or internet service providers on activities that have happened outside of the traditional walls of the organization, so to speak. And that's kind of where maybe we're a little bit different, but we'll kind of talk about that in a few, I would say. And with that, I'd like to just show you a little bit about Trace, and kind of, I'm forgoing the live demo, but I want to just kind of talk a little bit about our UI and what that looks like. So the platform itself, when we set out to build this, one of our tenets was to make deception, active defense, decoys, honey tokens, all these things that are really cool for research and stuff like that. We really wanted to use these in a more operational manner. So something that we could repeat, something that we could track over time, and something that was easy for a defender to employ without having to spin up a ton of infrastructure, without having to track manually track honey tokens, because at scale those things start to you start to second guess if that was the right one, for example. And so really what this is a view of is how we would build out a campaign. We start with a campaign. The honey tokens are assigned to a particular campaign, and they could be in forms of URLs, documents, honeypots, things that are part of that overall campaign. And the hits are actually logged within that campaign, so it makes it fairly easy to keep tabs on which tokens are performing, which ones haven't had any interaction, which ones are actually good to pull some threads. And that's where our analysis comes into play. So if we ever needed to drill into more granular logs, for example, if we needed to maybe drill into, in this scenario, drill into some of that network data to see if there's any correlation there, that analysis tab provides that. So right now we're still fairly early in a lot of the development of it, but effectively we are looking to operationalize a lot of those techniques. So we are cloud first. Our platform is made for the cloud and designed to be separate to reduce some of the risk to your organization. Again, we want to make the ease of deployment very easy, right? We want to make it that deployment time very low, bringing value on day one versus having to normalize data or sift through mounds and mounds of traffic. And our expertise is typically bundled with the products, and I would say that's one of our big differentiating factors for a lot of things. It's not just focused on MITRE pre-attack and things outside of the wire, but really what we want to say is that our expertise comes with the platform. So it's never a here's your new shiny tool, good luck, I hope it works out for you. It's about how can we be an added value to your team, and how can we actually help your business or organization understand their adversary problem. And with that, John, I will hand it over to you to talk a little bit about Corelight.
Thanks, Matt. Yeah, Corelight. So Matt mentioned a Corelight sensor in that diagram. What's a Corelight sensor? Well, Corelight, we make a range of network security monitoring sensors in various form factors. that basically give you commercial Zeek at scale. So all of the great capabilities of Zeek, the aforementioned logging and file extraction and custom scripting that I mentioned earlier, all of that is part of the Corelight platform because it's running Zeek under the hood. And we've done a lot of work behind the scenes to actually kind of move the ball forward on Zeek. And we've added a bunch of enterprise features that aren't present in the open source platforms, such as direct integrations with some of your favorite SIEM or security analytics providers. Scalability is a big reason that people often go with Corelight over open source Zeek. We've done a lot of hard work behind the scenes to get Zeek, very performant and very scalable. If you know open source Zeek, it's a powerful tool, but it's also a very tricky beast to master, especially at enterprise network scale. And packet loss and debugging and tuning can take weeks or months in some cases, or even years at very, very large organizations. We've even seen large Fortune 50 companies take years to fine tune their open source Zeek deployments. So Corelight is really commercial Zeek at scale. And we also now support Suricata in our AP3000 sensor on the right there. That's our top physical appliance sensor for physical network environments. But our goal is to give you that power of Zeek and network security monitoring in any network environment that you want. In this case, and today, as Matt showed you, that was in the AWS environment. So we've got sensors that run in AWS and Azure. We've got virtual sensors that you can run in Hyper-V or VMware environments. And we have a range of physical appliances that you can use in your physical network space. And, we just aim to make it really easy to set up. I mean, we've had customers that have been able to set up those appliances in a matter of minutes, plug it into a packet broker, connect it to their SIEM. They're off and running with that great data that we looked at today. So it's just a really easy, fast way to get Zeek data in your environment at scale. And so if you're interested, POCs are very easy. We can set you up with a POC and you can start, understanding the data set about your own environment today. And, we've got great customers. As a marketer here at Corelight, it's just a pleasure to talk to some of our customers and how happy they are with the results that we can deliver because they've already understood the power of this, visibility and monitoring, and they love what Corelight does for them. It, gives them the ability to focus their time on other things. They don't have to babysit and monitor an open source deployment anymore. They can actually focus on using the data, and that opportunity cost of time is huge in security. I mean, hiring great security people is one of the toughest challenges in security. And if you can take time that was otherwise spent babysitting a system and generating data and actually put those people back on investigations, you're going to be able to pull on more threads. You're going to be able to, set up a bunch of these honey tokens in a system like Trace and go pull on all of those threads fast because you've got people and you've got the data to do so. And so that's kind of, I think, one of the key values of Corelight is that we can give your analysts, rocket fuel data for their investigations, as we saw in today's webcast. But we also give people time back if they're already deploying open source Zeek, time that can be spent on more impactful security investigations. So with that, I think we're going to go over to Q&A. We've got a few minutes and time for some questions, and we've got a few questions here, Matt. So let me just pull up the next screen.
Yeah, absolutely.
All right. Let's see here. How about, I've got a question here. This will be for you, Matt. Do honeypots bring more risk to your organization, or do you think they can paint a bigger target on your back? Question mark.
Yeah, this is a common question, right? This is one that comes up frequently, and the answer to that one really, I would say, lies in how you've deployed it. And in some cases, a honeypot may just be an emulated system, but it probably is running on top of some operating system, whether it's a container, whether it's a actual full-blown operating system, right? And that's kind of where the risk lies. So the emulated system may only take you so far, but again, if you don't have a good way to deploy and manage those, those underlying operating systems, it could potentially increase risk. I think if you're deploying it in, say, like a DMZ, for example. And then, there's a lot of layers to that for sure. You might even say, well, is there more risk to, does that paint a bigger target on us and make our adversary more persistent? Sure, it could, but it also could make them say, hey, you know what, this is just a waste of my time, or I don't have time to spend on this. So it increases their cost both in money and time, and might say, hey, we're going to move on to an easier target.
Great. We've got another question here. I think I'll take this one. Beyond the SSL log, what other types of encrypted traffic insight can Zeek offer? Good question. So I mentioned that kind of Zeek's approach is around analyzing the handshakes and the certificates associated with those handshakes when it comes to encrypted connections. So in terms of encrypted traffic logs, there's an SSL log, SSH connections, which we didn't talk about today, get their own SSH log as well. Certificates themselves get their own log. So there's an X509 log that actually captures a bunch of rich detail about the certificate itself. So you can do things like get visibility into expiring certs or self-signed certs, which may be leading indicators of risk. And then the community itself has developed on top of this data set with the scripting capability of Zeek to squeeze even more insight out of these encrypted connections. And those are things like, I mentioned the fingerprinting technique on SSL. So a group of developers over at Salesforce who are open source Zeek enthusiasts developed a capability in Zeek, Zeek package that basically fingerprints and hashes the TLS client server connection. And so that's that blacklisting and whitelisting use case I described earlier. So now you've got the ability to say, I know that these are known good encrypted connections in my environment, whitelist them, alert me anytime I see something new in this particular IP space. And now you've got insight into anybody connecting over an encrypted connection who isn't using a whitelisted connection. And that's great insight to have. And so that's the JA3 script. It's on GitHub. Again, this is open source, so it's all free. You can download it and experiment with it today. People also did that with the SSH connection as well and took a similar hashing approach as well. So there's a lot of encrypted insight. It's not just the SSL log in Zeek. All right, we've got a couple more minutes. Let's see here. I think this next question might be good for you, Matt. It seems like hunting insiders with honey tokens is a bit like entrapment. Is this the case? Are there legal repercussions for this ?
That's a great question, right? You got to ask yourself. I always frame this question in this light, right? So you got to ask yourself: is a decoy system that's maybe owned by your organization, is that considered a real system? And if so, right? Because it's a real system, it looks, it smells, it feels just like the other systems. Maybe not smells, but you know what I mean. I would say that no, it's not entrapment, and only if a few things are met. One, you have a good, for lack of a better term, an acceptable use, something that the employees might sign or acknowledge upon maybe employment, for example. And this is in the case of insiders that says, hey, we leverage, some verbiage in there that says we leverage, security tools to detect anomalous behavior, for example, or, the possibility of insider activity. Again, this isn't legal advice, so definitely this would be something you'd run through your legal team. But is it entrapment? In that regard, no, because you've already kind of preempted that with, hey, this is how you do things here, and this is how you're not to behave on these systems. Entrapment really is around law enforcement, right? So as a security professional, you can't really entrap anybody. That's the other thing. So will this stand up in court? Might be like the core question that's being answered, and it just depends, right? Is what's the evidence being provided, and how good is it preserved, and does it follow some type of chain of custody? If it does meet that threshold. So it's a complex question and answer that definitely my kind of too long summary version is that you should probably talk to your legal department about that first, if that's something that you would like to use for implicating like an insider, for example. So I hope that answers the question.
I think this next question is for both of us. Is a honeypot or honey token included as part of Corelight, or do we have a similar app server around it? So I think, yeah, just to be clear, these are two complementary technologies being offered by Corelight and Trace, but two distinct technologies. Matt, I'll try to paraphrase and tell me if I get it right. You guys are about helping manage the deceptive kind of plan, deployment, monitoring, and just overall ecosystem of deception. Whereas Corelight, we're in the business of kind of helping you understand what's happening on your network holistically, whether that's good, bad, or anomalous traffic. So no, there's no honeypot or honey token technology included in a Corelight sensor. That's something you would need to go to a trace platform for, but combined is kind of the complement of deception plus monitoring.
Yeah, that's so essentially, if you're a Corelight customer, basically what's happening is we're able to leverage Corelight as almost like a point of enrichment for our alert. So if we didn't have a Corelight sensor, okay, sure, we can get some of those alerts out of our system, but this just helps really address some of those questions that may be harder to answer without network traffic. And in our scenario, we talked about one system, right? In a real life deployment, there could be anywhere from 2 to, let's say, 20 systems, right? And so being able to see maybe lateral traffic moving between our decoys, Corelight is a prime candidate for that. And if you're already a customer, deploying a cloud sensor is as easy as setting up a VPC mirror. And if you're unfamiliar with that, essentially what that is these cloud environments for the longest time have said, hey, we're not going to support that. So your traditional network security monitoring didn't work well out there. You have to come up with some creative ways to get around it. But now they fully support basically like the equivalent of like a span port in more of a traditional enterprise. So you can span that traffic to a Corelight sensor across VPCs and stuff like that. It's actually pretty simple, and definitely something to check out if you're a Corelight customer in like AWS or Azure environments. So.
And I think, Matt, you answered 2 additional questions in part around kind of the deployment and how it works. We had one question about how the monitoring works in AWS, but you mentioned that VPC traffic mirror, which is AWS's native mirroring capability they released. And then we had another question around how does a Corelight sensor does the Corelight sensor act in promiscuous mode, and how would it integrate or relate to an existing IPS solution? So yes, Corelight sensors by default operate passively, or promiscuous mode, if you will. So they're operating on a live copy of traffic. It's not an inline sensor. Doesn't have blocking capabilities. But of course, the upside there is there's no performance implications when deploying Corelight. And so to get the Corelight sensor, that copy of traffic in a physical network environment, you're talking about a packet broker, an optical tap, a span port, some piece of hardware in your environment that's going to actually be generating that copy of traffic and managing kind of the inline implications of that copy, whereas Corelight just hangs off of that mechanism. And then in the cloud environment, of course, it's something like the VPC traffic mirror that Matt mentioned, which is Amazon's native AWS traffic mirroring capability that a Corelight sensor deployed as an AMI in the Amazon environment can natively connect to via API and get that traffic. So I think, let's see, we're almost out of time. We got a few more questions here. Let me see, Matt. I think this next one could be for you. Can you talk more about whether you think advanced attackers will actually fall for this stuff, or is this just catching low-hanging fruit? Question mark.
Yeah, absolutely. Well, if you go back to our classical denial and deception kind of examples, or if you've ever read the book The Cuckoo's Egg, right? There's some pretty interesting uses of deception that fooled even some of the best militaries in the world, or even attackers back 20 years ago, I guess. Will they fall for it today? It depends on how well you've created your deception plan and what you're trying to accomplish with it. Will this fool every attacker? Absolutely not. Do honeypots, can they be detected? Yes, they can. This isn't by any means a silver bullet solution, but it does give us an advantage and a potential to detect that behavior before it's in the network or before it's actually in your enterprise. Because if we can do that, we can potentially either redirect or even minimize some of that damage. So are they always going to fall for it? No, but if they are expecting it, you got to ask yourself the question, does that in and of itself help us be more secure, or does it make the attacker choose a different target because they're trying to be too cautious because they assume that you've deployed something like this? I think that's a fair question. you don't really know until you're attacked. So in our mind, we want to have the best ability as early as possible to do that.
Great. And with that, we're at time. Thank you everyone for joining us today. Matt, thank you for coming on the line and joining Corelight to present on this topic. A copy of today's presentation will be made available, a recorded copy, so you can share that with colleagues if you'd like. And yeah, tune in again next time for our next webcast. Have a great day, everyone. And with that, we'll conclude the webcast.